Hello, pre-calculus class. In this video, we're going to take a little bit closer look at polynomial long division and come up with a couple of theorems, and then I will show you a shortcut in the next video for all of this. So, yeah, I think it's useful to watch the non-shortcut here first, but if you want to skip right down, that's your prerogative. But we are going to do a couple of different things. We are going to evaluate this polynomial, have some polynomial function. We'll use p of x instead of f of x, just to get used to that. Polynomial function x cubed 2x squared plus 5x minus 6, and we want to find out what is the value when x is negative 2, what is p of negative 2, and what is the value at 3, what is p of 3. And then we're going to divide the function, the polynomial long division, by x plus 2 and by x minus 3. So let's jump right to it. We're going to start with a here. Just if I wanted to evaluate this thing, right, that's just plugging it in, right? If I put in negative 2 for x in all of my spots here, I'm doing negative 2 cubed plus 2 times negative 2 squared plus 5 times negative 2 minus 6. Negative 2 cubed is negative 2 times negative 2 times negative 2. Negative 2 times itself is positive 4 times negative 2 again makes negative 8. Negative 2 squared is positive 4 times 2 makes positive 8. Right? 5 times negative 2 is negative 10 and then minus 6. Right? And I end up with p of negative 2. Negative 8 plus 8 is 0. Minus 10 is negative 10. Minus 6 is negative 16. Okay, I'm going to jump straight over here and I'm going to do part C next, I guess. I maybe could have done A, B, C, D, but yeah, too late now. I'm going to find out what is p of 3 here, right? And so that, again, I'm just going to put in 3 for x. So I'm going to have 3 cubed plus 2 times 3 squared plus 5 times 3 minus 6. 3 cubed is 27. 3 squared is 9 times 2 is 18. 5 times 3 is 15 minus 6. And so I end up with p of 3, the value of the function when x is 3. 27 plus 18 is 45, plus 15 is 60, minus 6 is 54. Okay, so I've got p of negative 2 is negative 16, right? P of 3 is 54, and now let's do the parts b and d. Right? Part b here says we want to divide p of x by x plus 2. And so I showed you a couple of different ways that you can kind of do that in the last video. One is just the polynomial long division. So I'll do that for this example, and then the other one I'll kind of do my weird Mr. Vis way, just trying to find that factor directly. But so I got x plus 2, right? And I want to find out how many times that go into x cubed plus 2x squared plus 5x minus 6. Again, we start on the left side. I want to find out what times x plus 2 will give me x cubed, right, to start with. And so the first thing I'm going to need is an x squared. Right? When I do that, I get x squared times x makes the x cubed term I was looking for. X squared times 2 is 2x squared. And hey, I knocked out both of those terms with just the one thing here. Right? So if I were to subtract this whole thing, 2x squared, sorry, x squared times 2 is 2x squared, subtract this, this goes to 0, and so does that, right? And I'll drop down the 5x then. And so I want to figure out next is how many x's times x would give me 0. Well, I don't want any, right? I should have a 0x here. When I do that, 0 times 0x is 0. Times x is still 0. I didn't mess up the x squared terms that I already got perfect with just this piece here. Right? 0 times 2 is 0. Right? I have 0 x squareds. I have 0 x's. But I wanted there to be 5 x's. Right? So when I had that, right, now I need to create 5 x's because I don't have that yet. So last thing, right, I need to make the 5x minus 6. Well, how many times do I need to multiply x by to get to 5x? It's going to be 5 times. So 5 times x will make the 5x's that I need. 5 times 2 makes 10. When I get rid of that, though, it looks like I kind of overshot this thing, right? I wanted there to be negative 6 at the end, but I made there be, right, well, yeah, I just made there be 10 there, so I'm off by 16, right? This is my remainder, right? This negative 16 here is the remainder that I got, right, when I divided p of x by x plus 2. Right. That remainder, coincidentally, was equal to the value of the function when I put in negative 2 in here, right? Like if x, think of like the 0 piece here, it's the opposite of the plus 2 here. When I put it in negative 2, I got that negative 16, right? Okay, so I have this remainder. What do I do with those remainders, right? What this is really saying is that, right, if I were to do x cubed plus 2x squared plus 5x minus 6, and I were to divide that by the quantity x plus 2, that would give me x squared. 0x's, you don't need to write those in. I'm just going to do it for, right, like the effect here. Right, plus 5 minus 16 over x plus 2. That's how I deal with that remainder, kind of like that mixed number. Right? We kind of looked at it here. Right? When I have that remainder, it goes on top of, right, that thing that I'm dividing by. Right? Right. So I could write that too without the x term here. I'll just write it as x squared plus 5 minus 16, or maybe even plus negative 16 over x plus 2. Either way is fine to write this. So just a quick note, right? You kind of think of this, maybe this is like an improper fraction where you have some big thing on top of some little thing. So we can just kind of call that like an improper fraction form. Really, you're just dividing, right, a polynomial by another smaller polynomial. This is what the book calls, and you'll see this in your questions a couple of times, what they call mixed number form. Because it looks like a mixed number, right? Like if I again go back to here with this is an improper fraction, the 5739 divided by 4. This is a mixed number, and so this kind of looks like that second thing where I deal with that remainder there. So, okay, let's maximize this here and see if that coincidence holds up over here, right, with this part D here. Again, D, I said I'm going to do kind of my weird Mr. Vis way, where I'm trying to think, right, x minus 3, right, if I divide this polynomial, this whole thing, by x minus 3, what I'm looking for is x minus 3 times what will give me x cubed plus 2x squared plus 5x minus 6. So these are just, right, the B and the D here. I'm going to do them two separate ways, but I'm accomplishing the exact same thing, right? So what I'm trying to do when I do it this way is I'm trying to kind of just create this. Like what do I have here? And I think I actually need to slide this over just a little bit because I'm going to need some more room here, right? What would need to go here that when I multiplied it by x minus 3 would give me this? That's what division is, right? Again, if I do 15 divided by 3, saying, well, 3 times what would make 15? That is the action of division, is thinking like what's the leftover part, right? So I'm just going to do that kind of explicitly here. Say, right, if I did that and I have x minus 3 times something makes this term here, the leading term here has to be an x squared term, right? And if I do that, I have x squared times x is going to make, right, an x cubed, and then the negative 3 times x squared is going to make negative 3x squared, right? I wanted there to be 2x squareds. I just created negative 3x squared, so I know the next piece in here needs to be, it better be a plus 5x squared, because then that will make a 2x squared term like I want there to be. Right? So how am I going to introduce that 5x squareds? Well, by multiplying x times 5x. Right? That will give me my 5x squared term that will give me, like, satisfy the x squared requirement here. But I'm not just multiplying x by 5x, I'm also doing negative 3 times 5x. So that makes negative 15x. I don't want there to be negative 15x's. I want there to only be, right, 5x's. So my next term in here needs to be a 20x, right? A plus 20x, so that when I put these two things together, right, I make a 5x, right? So how am I going to get 20x's? By multiplying x times 20. Right, so I'll do x times 20 to get the 20x's, but again, I have to do the negative 3 times 20 as well, which gives me negative 60. And I don't want there to be negative 60. I only want there to be negative 6. So again, what's the last piece that I need to be here? Well, my next thing better be a 54. So that when I put those together, I get minus 6. And then I'll have, right, the x cubed plus 2x squared plus 5x minus 6. Well, how am I going to make a negative 54, or sorry, a positive 54 here? Right? Like, there's no way to get just 54 with this unless I do this. Right? I write this as plus 54 over x minus 3, because if I did this whole term times that thing, I would get my x minus 3's will cancel out, and I would just be left with the 54 there. Right? So that's not really I'm not doing 1 and 2, I'm doing this holistically. I'm doing this whole thing, 54 over x minus 3, times the quantity x minus 3. So this whole thing, nope, I want to do this in gray, keep my colors consistent. I'm doing that whole thing times that whole thing. Right? When I do that multiplication, I will get this, x cubed plus 2x squared plus 5x minus 6. Right? So that, right, again, just think if I did this, x times x squared is x cubed, negative 3 times x squared, negative 3x squared. X times 5x makes 5x squared. Put those together, I get the thing I want. Keep going down the line. I'll get that whole piece out. So what this is telling me, right, I know that x cubed plus 2x squared plus 5x minus 6, if I were to divide that by x minus 3, I will get x squared plus 5x plus 20 plus 54 over x minus 3. Again, my improper fraction form, and here's my mixed number form result on the right-hand side. And again, that remainder, this 54, is the same. The remainder that I would get, if I did this the polynomial long division style, I would get that same thing. That would be my remainder. And the remainder is equal to the 54 up there. Right? This is actually a theorem, right, in mathematics. And they call it, right, properly named, the remainder theorem. Right. And the remainder theorem states that if p of x is a polynomial function, then p of c, nope, not x, p of some value c is equal to the remainder when p of x, the polynomial function, is divided by the quantity x minus c. Okay. So if I put in some number, -2 or +3, in for c, that's equal to the remainder that I get when I divide by x minus c. Up here it was x minus -2, which those double negatives we usually write as x plus 2, or here x minus 3. The remainder is equal to the value of that. And then there's a corollary to this. Some people say corollary, some people say corollary. I'm okay with either one. A corollary is just something that, like, it's a natural connection to this first thing. Like, because this is true, then something else is basically automatically true. We give this one its own name as well. Right? These are kind of like your first theorems that we were doing in pre-calculus here. But they call this the factor theorem. Right? And the factor theorem says that the quantity x minus c is a factor of polynomial p of x if and only if p of c equals 0. Okay. So this is a factor if and only if the result that I put in there is equal to 0. And that's what we were doing in the last video, where we got 0 out. So this is then an even, clean factor with 0 remainder, right? We do this with numbers, right? Think like something that is a factor, right? I know 2 is a factor of 8 because 2 goes in evenly to 8. It divides into 8 4 times with no remainder, right? 3 is not a factor of 8 because 3, when I divide it into 8, I get 2, but then there's this remainder of 2. If I divide 8 by 3, I get 2 2/3. Right? So if the remainder is 0, right, then I know this thing is a factor, right, because of this theorem here that says if I do x minus c, right, if I divide that and I get some remainder, then it has some value, right? It's not equal to 0. It's somewhere else above or below the x-axis. But if I do that division, right, if I factor it out, I divide by this quantity and get a remainder of 0, then I know that that has to be a 0, and vice versa. If it's a 0, then x minus that value has to be a factor. And so that is the kind of fundamentals of all of this. The theorems, each of this, the remainder theorem, factor theorem, right? Actually evaluating it, seeing the remainder, doing the long division. In the next video here, I'm going to show you a very quick shortcut to kind of achieve all of the stuff that we've done above. Right? This is great stuff. It's a very fundamental understanding of all of this. And now I'm going to show you a really quick, easy way to kind of accomplish this entire page.